in one of my classes, I wrote this addition problem on the board. And I wrote the word how, meaning how is this possible? They had never seen non-base 10 numbers, so this looked like a mistake on my part, or some mysterious kind of math they had never seen before, which it kind of is, but it's actually not that mysterious. Math is supposed to be the universal language, or at least many people think of it like that. Addition is addition, multiplying is multiplying, it's universal. But if you were to go to another planet, it's actually not necessarily the case that on that planet that 3 plus 3 equals 6, or even 3 times 4 equals 12. It's not necessarily the case because of the symbols that we use and also the way that we count. Yes, addition may be universal, but how do we know that they count in the same way we do? And this is what I mean. When we read a number like 1, 5, 4, we read that as a 3-digit number with 4 in the ones place, 5 in the tens place, and 1 in the hundreds place. That's the way we've been taught ever since kindergarten, first grade. These are the place values. But how are we so sure that someone in another culture or another planet also uses the ones, tens, and hundreds place? Why do we even use the ones, tens, and hundreds place? There's no way to really know. My theory is that the reason we have the ones, tens, and hundreds is that the number 10 is really important to us since we have 10 fingers. Most likely that's why we started using place values that are powers of 10. Or it could just be a simple fact of 10 things is 10 objects, like 10 sticks or 10 rocks. That's a nice amount. It's manageable for our brain to picture what 10 things looks like. It's also manageable to carry 10 things if they're not too big, if the objects are not too big. But 20, 30, that's hard to picture. It's hard to carry 20, 30 sticks as opposed to 10 sticks. In any case, most of the world counts in base 10. Well, we need to remember what these place values, where these place values actually come from. I keep repeating base 10, but what does 10 have to do with the hundreds place or the thousands place, for example? Well, the ones place is called the ones place because it's really 10 to the 0 power. The tens place is called the tens place because it's really 10 to the first power. And the hundreds place is really the hundreds place because it's 10 to the second power. And so on. So every place value is a power of 10. Okay, so let's go with my theory of the 10 finger theory, and that's why we count in base 10. What if on a planet everybody had 6 fingers, not 10 fingers? In that case, it's unlikely that they would have developed a base 10 counting system. Maybe they would have, but let's say for the sake of argument they didn't. If they didn't, what would their place values be? So I'll just call this, so on planet 6, because everybody has 6 fingers, Most likely their place values would have been 6 to the 0 power, 6 to the first, 6 squared, 6 cubed, and so on. And so their place values would have been called the 1s, the 6s, the 36s, the 216s, and so on. So let's put some digits in here now. One, two, four, three. So let's write that number normally. 1, 2, 4, 3. On planet 6 does not mean 1,243. When we say 1,243, that's Earth language. We're using base 10. When we say 1,000, we mean 1 10 to the third. When we say 200, we mean 2 10 squareds. When we say 40, we mean 4 tens, and then 3 means 3 ones. But on planet 6, when they say 1, they don't say 1,000, they say, I don't know what the word would be, but that 1 represents 1 216. This 2 represents 2 36s. This 4 represents 4 6s. And this 3 is just like our 3, it represents 3 1s. So this 1, 2, 4, 3 number in base 6 is really 216 plus 2 36s, so that's 72, plus 4, not 10s, 4 6s, that's 24, and then 3 1s. So this is what these digits mean in our language. So now I can add these up in our language. Did I do that right? Yeah. So 1, 2, 4, 3 in base 6 is equivalent to 315. So if someone from planet 6 visited our planet and wanted 1, 2, 4, 3, I don't know, 1, 2, 4, 3 apples, and wrote down the number 1, 2, 4, 3, you should not give him 1,243 apples. You should give him 315 apples because he only wants that many. So if you laid out all those apples, those 315 apples on the table, that is universal. That group of apples, that's universal. It looks the same to everybody. But the way you communicate through numbers what that amount is not universal. It's 1, 2, 4, 3 on planet 6, and it's 3, 1, 5 on our planet. Okay, so now that we know how to convert a non-base 10 number into a base 10 number by setting up the place values, we can practice doing this with other non-base 10 numbers. So let's do that with 213 base 5. Okay, I need the place values first. So in base 5, the place values are 5 to the 0, 5 to the first, 5 squared. So that's 1, 5, 25. Those are the place values. And in this case, I have 3 1s, I have 1 5, and I have 2 25s. So 213 base 5 is the equivalent of 50, that's 2 times 25, plus 5, that's 1 times 5, and 3. That is 58. So someone counting a base 5 wants 213 of something, you give him 58. Okay, let's try a large base. Let's say 4, 2, 6, base 8. Alright, my place values are a to the 0, a to the first, 8 squared. That's the 1's place, the 8's place, and the 64's place. It sounds so weird to say that. Okay, so 4 in the 64's place, 2 in the 8's place, and 6 in the 1's place. 4 times 64, 256. 2 times 8, 16. 6 times 1, 6. And we got 272 plus 6, that's 278. So 426 base 8 is 278. Now let's try a really small base. Let's go with 110101 base 2. That's 6 place values, so need some room here. 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth, I need 6 of them, one more, 2 to the fifth. I got the 1's place, the 2's place, the 4's place, the 8's place, the 16's, and the 32's. And now I put these digits in. Okay, going from left to right. I have 132. I think I'm going to add these vertically. 16. No 8's, so I just skipped that. 1 4. No 2's, and a 1. $53. So this 6-digit number in base 2, 110101, is only 53. Okay, so we have converted from non-base 10 into base 10. How about the other way around? Let's go with 181, and we're going to convert that into base 4. 181 into base 4. Okay, first I need the place values again. So the first place value for base 4 is the 1's, and then the 4's, and then the 16's, and then the 64's. And if I went one more, the next place value would be the 256's place. But since that's higher than the number I'm using, I don't need that. So I know that 64 is going to be where my first digit is, in base 4. Okay. Now remember, this is a base 10 number, a base 10 number. And I generate the digits in base 4 from these place values. So I need to ask myself, what is the largest multiple of 64 that goes into 181? Or I'll ask it this way. How many times does 64 go into 181? How many times does 64 go into 181? That is the digit that will go here. So it can certainly go in once. It can go in twice. That's 128. If I go 3 times, I'll just check what that is. That's 192, which is over, so I'm going to go with 64 goes in 181 2 times. That's 128, and I'm going to take away 128 from 181 because that I've used that up. I've used up 128 of the 181 by placing it here. This 2 represents 2 64s, a grand total of 128. And then we'll see what I have left over. I have 53 to play with. Now I go to my next place value, 16. How many times does 16 go into what I have left over? 53. I know 16 is times 3. 16 times 3 is 48. So if I take 3 16s and subtract from 48, I have 5 left over. I have 5 to play with. Now I go to the 4s place. How many 4s can fit into 5? Exactly 1. Well, not exactly 1, but 1 can fit in 5, so I take away a 4, leaving a 1, and exactly 1 1 fits into 1. Whoops. Subtract 1. And I've used up the number. So 181 is 2, 3, 1, 1, base 4. Okay, let's do this one more time. We're going to convert 109 to base 2. I start by building my place values. The 1's place, the 2's place, the 4's place, the 8's place, the 16's, 32, I'm going to run out of room, 64, and that's the last one. Okay, so I ask myself how many 64s fit into 109, and that's just 1. I take that 64 away. Oops. $45 left to play with. How many 32s fit into 45? 1. 13 to play with. How many 16s fit into 13? None. I go to the next one. How many 8s fit in 13? 1. How many 4s? 1. How many 2s fit into 1? None. How many 1s fit into 1? 1. I've used it all up. 109 is 110, 1101, base 2. Okay, so that's how to convert from non-base 10 into base 10, and base 10 into non-base 10. Thanks for watching K19 Math. Have a good day.